And hi, everyone. Thank you so much again for joining us for another session of JNation 2020 Online. So we're now on our fifth session of the day, and we have here with us Elder. Hey, Elder, how's it going?
Hey, Alberto. Nice to have you. Actually, thank you for having me, and nice to
Yeah.
meet you again, my friend.
Well, I mean, it's us that has to thank you for being here with us. Yeah, we will really be happy to have you here in Portugal. Unfortunately, we cannot make it this year. Have to do it online, but maybe next year we can bring you and do it here physically in Portugal.
Yeah, hope
And
so.
especially because we both speak Portuguese, right?
Yeah.
Uh, anyway, so Elder is gonna introduce to us and talk a little bit to us about a very exciting technology called Graal VM. It's something I've been looking in the last 2 years. I think it's a really cool technology, and I'm really happy that Elder can bring a little more light into this subject in Generation 2020. So please, Elder, whenever you're ready, feel free to go.
Okay, guys. So thank you very much again to Roberto and to all organizer of J Nation. As Roberto said, I was supposed to be there in last year. I couldn't make it. I was supposed to be this year, and no one could make it. But I'm very happy to be with you guys and girls online right now. So thank you for the organizers. Thank you for you that is attended to this event, to this awesome event. I'm very humbled to be here. So let's change my screen. As Roberto said, I will talk to you today about Graal VM. So this is my session, the question language Graal one JVM to rule them all. So I'm Elder Moraes, and I work at Redhead as a developer advocate. So let's start by a demo. Okay, let's start with a demo right away because I would like to bring you to this content right now, and then we talk a little about it. Okay, so let's start here. If you ever heard about Graal VM, maybe you heard that Graal VM is fast. Maybe you heard that Graal VM make Java faster. So let's try it, okay? What I have here right now, let me just switch my notes. I have this class. It's a simple Java class, okay, that will do some iterations and should got a phrase, a sentence, and count how much uppercase characters that we have in that sentence, okay? So let's switch to my terminal. What I have here is Graal VM 20, all right, the community edition, and it is based on Java 11, okay, OpenJDK 11. So let's compile that class, count uppercase, okay, and then right now let's execute and got the time that we take to execute this sentence. So Java count. In 2020, I would like to run all languages in one single JVM. JVM. Okay, so this class will count how much uppercase that we have in this sentence. Okay, so we have the count, and here we have the time. So 1 second and 411 milliseconds. Okay, it's fast. Okay, and here we are using Graal VM. What we are really using here from Graal VM is the JIT compiler. Okay, it's the compiler that make the improvements on our Java code while it is running. Okay, so here we are using the Graal VM JIT compiler. So let's have some comparative. So here I will run the same command, but without the JIT compiler from Graal VM. Okay, so I will just execute again, but remove the Graal VM JIT compiler. Sorry, use JVM CI compiler. So I will run the same command, but without the git compiler from Graal VM. So with Graal VM, we had 1 second, 1 second and a half, okay? And without Graal VM, we have almost 3 seconds, okay? In my machine here, we have some variations because I'm streaming, I'm running a lot of things, but in a common, very usual try, let's try again with the Graal VM, almost the same, 1 second and a half, and without Graal VM, almost 3 seconds again, okay? So it's very, very fast because with the regular JVM, with the regular git compiler, we don't have the same improvements that we have with the Graal VM compiler, okay? And let's try another example here. I have another class. This is this class here. Let me show you guys. Is the top 10. Where are you? Here. Okay, another simple Java class that will got a file, a text file, and will count the top 10 words that we have more occurrence inside the file. Okay, so let's compile the top 10. All right, I have here, let me create the file, so small. And this file is very tiny, less small. Okay, we have a 1 kilobytes file. So if we just ask to count the top 10 words on this very short file, it's fast, okay? So it's 145 milliseconds. So you look at it and say, well, it is fast, it's very fast. But what if I told you that it's not fast enough? It could be much more faster, because it could, because this file with 1 kilobytes it should be much more faster to read this file. So how can we do that? By creating a native image. Server top 10. Okay, what are we doing right now? So Graal VM, using the native image feature, is collecting all the dependencies that is needed to run this class, and it's performing all the executions that the JVM would do when we are bootstrapping this class, and it's processing all this processing the process while we are compiling this native image. Why it is doing that? Because once we run again this executable, we don't even need a virtual machine running, because we have all embedded in this file. And this file is not so big. If we got here the top 10, it's an 8 megabytes file. 8 megabytes to perform whatever this file would be performing if we were using JVM, okay? So it's very affordable. So let's compare. We got here the time, top 10 small, 150 milliseconds, okay? And let's switch to the native image with top 10. Let's try again. Okay, my machine is making some variations. So here with, okay, 149, and here 19 milliseconds. So almost 10 times faster than if we were using a regular approach of running a Java file using the virtual machine, okay? Of course, it's not a silver bullet. You wouldn't use it for any kind of situations. But for example, in some situation where you need a really fast bootstrap that will answer something really fast and then shut down, it could be an option for you. Okay, so this is the first demo, and let's switch to our presentation. Okay, so talking about me very briefly, my name is Elder Moraes. I work for Redhead as a developer advocate. I'm based on São Paulo here in Brazil, and I'm responsible for Redhead Developers here in Latin America. At this QR code, you would find my channel where I share some content about microservice, Java, containers, Kubernetes, cloud native, and on weekly basis I share content both in Portuguese and English. So I know this event is based on Coimbra, so maybe our friends that speak Portuguese could have some use of my content. And if you are not Portuguese speaking, you have also some content in English. Okay, so the QR code or the URL bit.ly/elderyt.
Well, even if you're in Coimbra, we have a lot of people in Portugal. So even people from Lisbon, Porto, Algarve, Faro, Villarreal, Braga, all of us are watching us. So that's fine. Not only from Coimbra, Aveiro.
Amazing. Thank you, Roberto.
Yeah.
Yes. Portugal, okay, or Portuguese speaking guys. Thank you very much, Roberto.
Sorry about that.
No, man, come on. you are my king here. And guys, I wrote a book and this name is new, actually new, Jakarta e-cookbook, because I wrote the first edition, was published in 2018, Java e-cookbook. And this very week, on June 5th, we are going to have the Jakarta e-cookbook being released. So tomorrow I will release a special condition if you would like to acquire this book on very release date. So I will publish it on my channel also. And as a developer advocate, my mission, my life mission, is to help you developer to deliver the best applications and projects and code that you was supposed to deliver. Okay. All right. When we think and when we speak and when we talk about Graal VM, I like to have an approach using three main contexts. Okay, three main pillars of Graal VM scene, Graal VM context. Okay, first is performance. Why? Because usually you only have a high performance, a good performance for languages that have a high investments, the big language. Okay, so if you look to the biggest languages in the market, usually they have good performance rates. But the Graal VM proposal is to bring high performance for all languages. Second pillar is interoperability, so polyglot programming and so on. So usually when you need or when you would like to have this kind of approach, you have a high cost for serialization. And I'm going to show you in a few minutes what is that. And the proposal of Graal VM is to zero the overhead of interoperability between different languages. And third is tooling. Usually you need to have tools for every language. So for profiling, for debugging, and so on, every language has its own tool. And the proposal of Graal VM is to share tools between all language that runs inside Graal VM. So let's first talk about performance. I just showed you a part of my demo about performance. And we have a benchmark that was made regarding to different languages, and we got here this comparative. And it's important to say that performance is not exactly something to say that a language is better than other, okay? Because each language has its own appliance, his own way to be used. So, for example, I have friends that use R, and they are happy with the performance that R provides because in the way that they use, it's okay. Okay, so it's not a measure of being best or being worse language. It's just a comparative of performance. So here we have this comparative performance of language, and the proposal of Graal VM is to bring all those languages to the same level of performance, okay, to the same bar. So where you can bring all those languages to something around Java and JavaScript and C and C++, okay? So this level of performance. The other example here, we have a math function performing in different environments. And in these two bars, these two first bars here, we have the same math function that was tested running just Graal VM with just Ruby. And in the second scenario, second bar, we have Ruby and JavaScript. And notice that we don't have any loss of performance. We have like 90 million operations per second. And here we have other scenarios like JRuby with Rindy and Reno and whatever other scenarios. And the performance even reach 100,000 operations per second. So it is very, very fast. And what's the secret? Why Graal VM is so fast? Because one thing called Graal compiler. And the Graal compiler is the JIT compiler that is embedded on Graal VM. I just showed you an example where we have the JIT compiler of Graal VM acting in a very few lines of code there. And they spend a lot of time really improving the JIT compiler for Graal VM. And the very same JIT compiler that is used for JIT, for just-in-time compilation, they use also for ahead-of-time compilation. So they make a way to reuse the same algorithms, the same process of compilation to have the ahead-of-time compilation. And another thing that is very interesting about this Graal compiler is that it is written in Java, okay? And the engineers report that by being written in Java, it's much more easier to evolve, it's much more easier to maintain, and it is even have more possibilities to optimization than C++. The regular JIT compiler is written in C++, and they reported that Java provides much more possibilities of optimization. So the next time that one of your friends say to you that Java is slow, you can answer that Java is being used to improve Java. Okay, so Java is really fast if you use the right way. And of course, in years and years of research and work, just a briefly story here. The project of Graal compiler was born on Sun Labs. Okay, so back in maybe 2008, 2009, and when Sun got bought by Oracle, the Sun Labs became Oracle Labs, and since then we have this project being developed. So if you look at the Google, you'll find some academic articles about Graal compiler back in 2010, 2011, 2012, and so on. Okay, so it took a lot of time to really deliver a good tool. So a little about interoperability. So how we approach to polyglot applications using Graal. In a regular scenario, okay, if you would like to have communication between different languages, you will have something like this. So, for example, your Java code will pass to the implementation layer and then to the virtual machine layer. And here we have serialization. And here we would go to another virtual machine and deserialize and go to implementation and go to JavaScript. So we have this process. And this process is expensive because you have a lot of layers, different layers, and a lot of process, especially the serialization is very expensive to maintain. So if you could have the virtual machine layer being brought to this approach here to have a single virtual machine, it would be very better, much better, because you will eliminate one of the layers. But you still have the layer of implementation that is still costly for your project. So the best would be to have this kind of approach. So the virtual machine and the implementation of them in the same layer. So we have that proposal of Graal VM that's zero overhead for polyglot communication. And here we have another actor inside the Graal VM world that is called Truffle. Okay, Truffle is a framework embedded on Graal VM virtual machine that is made for language implementation. Okay, so it make possible that you got some language that language was not made to run on a Java virtual machine, and you make an implementation so that language can run inside a Java virtual machine. So by doing that, Truffle will give you a JIT compiler for that language that is being used on Graal VM. So for example, JavaScript today runs on Graal VM. So by using Graal VM, that implementation of JavaScript that was written using Truffle, Truffle is giving to JavaScript a JIT compiler. The same for Ruby, the same for Python. And whatever language that comes to run on Graal VM, we have a JIT compiler for that language. So today, if you download and use Graal VM, you have a JIT compiler for Java, of course, because it's made for that, JavaScript, Ruby, R, and Python. So just to have a big picture, here on bottom of all these different parts, we have the hotspots. And on top of hotspot, we have the JVM compiler interface. And then we have just accommodate here. And then here we have the Graal compiler. And on the level of Graal compiler, we already have the Java, Scala, and Groovy. Of course, they was born to run on virtual machine. And on top of Graal compiler, we have the Truffle framework. And here we have Ruby, R, JavaScript, and Node.js, and Python. These are implementations of those languages made on top of Truffle framework, so they can run on top of a virtual machine. And we have also another module inside the Graal VM that is Sulong, where you can run low-level virtual language, so C++ and C. And it is interesting that Truffle makes so easy the life of writing an implementation of some language that I don't remember exactly what language. I believe it's R, but I may be wrong. But I believe that our implementation that is running inside of Graal VM was written by an intern of the team in 3 months. So they wrote an implementation of the language in 3 months by using Truffle. Okay, so it makes your life very easier. So here is an example of the Truffle API for polyglot code. Okay, so if you would like to implement a polyglot code using Graal VM, you're going to use the Polyglot API that is provided by Truffle. And here's an example. So we have the Polyglot, have an instance of this Ruby library, okay? And here, this library is being used on a JavaScript code, okay? So we have here a mix of 2 different languages in a single program. And here we have a disclaimer. Here we have an important, very important alert for you. The point is not to mix code of different language in the same program, okay? Because I don't know if you guys remember of Katy Sierra. She used to write books of Java certification back in the 20s. I read one of her books for Java 6, if I don't remember. And she wrote in some part of the book something like this. Create and develop and write your code as if the person who will maintain your code is a serial killer who knows where you live. Okay, so make a good code. Don't make the life of the people that will maintain your code miserable. Okay, and if you mix different languages in the same code, maybe you make their life miserable. So what if I can't do, and I'm not saying that you can use, but that you should not use it, But what's the point of having this possibility if you should not use it? First, because by having this possibility, you can have an interchange of the library between different languages. So for example, if you have a great library written in Java and you would like to use that library on a JavaScript application, great, you can use it because usually you should have a new implementation for JavaScript of that great library. But by having this possibility, you don't need it to do that. Or you have a great library written in Python and you're gonna use it on your Java code. Okay, great. You can use it by just using that Polyglot API. And the second reason is that you can select the language for your project by selecting your preference or the best language for that task, and not the language based on performance, for example. Because sometimes we have this situation where, well, I like Java, but for this project I should be using C++, for example, because it's faster. Okay, by having this possibility, you don't need to do that. Okay, you can choose your preferred language and go ahead because Graal VM will provide you the same performance. All right. Okay, let's go now with tooling. Let's go with tooling. Let me just check here my screen. Okay, tooling. All right. So if you are a Java developer, you probably are used to high quality tools, okay? And not just Java, other great languages, they have great tools because of that high investment that I told you in the beginning of presentation. All the languages that have high investment, they usually have high quality tools, okay? But if you are not a developer of one of those languages, maybe you are not used to so great tools, so high quality tools. That's when we have Truffle again to the rescue. Why? Because Truffle has an API, Truffle's tool API, where you can write tools to run on top of Truffle, and that tools that you write on top of Truffle will be available to whatever language that is running on top of Truffle. So that's the third point of our pillars, where you can have tools for whatever language that is running under RhoVM. And now here we have more demos. Okay, so now we make our offers to the demo gods. Okay, so please, demo gods, make our demo work. And
I'm pretty sure it will work. No worries. So let's chant for the demo gods.
Okay, thank you, thank you guys. And I'm gonna have a little water here because this is the most excited part of the talk. Okay, guys, so let's switch to my notes, and you already saw this code here. Okay, what I'm going to show you right now, it's an example of polyglot code. So what I just told you, not do that, okay, but I'm going to show you how you would do that. And here is an example of a good use because we are just using a library for other language, okay, so this is okay. So here we have, as you see, a JavaScript code, okay? And we have an instance of big integer from Java. And this big integer is creating a big integer number here for us. And here we are using our library, okay, a library from our language, using the Polyglot API. And then we are gonna have this graphic being showed to you using a Node.js endpoint here in this case, okay? So let's just got here the terminal, okay? So this node here is using a feature from Graal VM, and here we are telling the Graal VM that we are gonna use a polyglot approach. It's running inside the JVM and this file, okay? So let's start, and while it's okay, it's available. Let me just open browser here, and we have localhost. Okay, so now it's plotting the graphic. Takes some seconds because the number is really, really big, but it wouldn't take too long. Okay, so here we have the graphic plotted by using an R library with a number generated by a big integer from Java and in a JavaScript application. Okay, so this is one way to use Polyglot development. Also, I told you about the tooling, that we can have tools being shared by different languages. So I'm going to show you right now. Some of you maybe already know the Visual VM. So here we can have a lot of information about our VM that is running here. So it is the Java 11, as I told you. All right, so monitor, we can have heap dump, a lot of information for our heap. Okay, so what I'm gonna do right now is to monitor a Java application. Okay, so I will make that top 10. Remember top 10 that we used to read a small file. We are gonna use it to read right now a large file. This file is, I believe, 140 megabytes. I'm gonna check. That's large. Oops. Yeah, 144 megabytes. Okay, so let's read this file using the top 10 large. Okay, so it's opening a process here. So we can monitor, we can see what is happening, the garbage collector, the threads, and whatever. I can go here to the monitor and get the heap dump and see what is happening. Okay, all right, it's a Java application. It was supposed to work on the Visual VM. But what about, for example, a Ruby application? Ruby application was supposed to work on Visual VM? No, because it's not based on a Java virtual machine. But by using Graal VM, yes, we can do that. And here, this Ruby, of course, is running under the Graal VM. And here I'm telling that it's a JVM application. And it will run using JVM features. And this is the Ruby file. Let's wait here. Okay, it's running. So we have a Ruby process running under the JVM. So we have the same features, the same tools, the same behavior that we have in a Java application by using the RhoVM with this guy here. So I can have even the heap dump as it was a Java application. Okay, so that's the power of having the tools being built on top of Truffle. So let's stop here. Another example here that we have is, just let me show you the code. It's the distance. Where are you guys? Here. So another simple example, it's basically this application here will have the calculations between 2 points on Earth and the distance, but it is using a third-party library. Okay, so if I would like to, for example, compile this Java class, I will need to reference this third-party library, and the same way when I would like to execute, I will also make the reference, okay? But if I use the native image that I show you in the beginning, what I'm doing right now, remember I told you that when we are creating a native image, they are not, the native image is embedding all the dependencies inside this native image that's been generated. So here, this third-party library is one of the dependencies, so it is being also embedded. So the native image will not only make your executable run faster and run smaller, run simpler, but also the way that you use it is much more simpler because we don't need to reference any dependency anymore. It's almost finishing here. So we run the code right just like this. And if we are using with the native image, we just call the native image and pass the parameters without any reference to third-party applications, okay? So 16 milliseconds here. All right, and the last thing that I would like to show you right now, it's about Quercus. And why should we talk about Quercus here today? Because let me just get the CD code. No? All right, so I will. Damn it.
No worries.
Okay. Oh no, code with Quercus, yes. CD code, yeah. Thank you, Roberto. Okay, Quercus. Why we are supposed to talk about Quercus here? Because we have some misunderstanding. I saw a lot of times because some people understand that Quercus is fast because of Graal VM. And actually, Graal VM is one of the features of Quercus because when you would like to run Quercus with native image, then Quercus use Graal VM. But Quercus is already fast without Graal VM. Okay, so it is just faster when you use Graal VM. So here I'm going to show you a really quick example. So Quercus dev. It's when you go to the code.quercus.io, you can create a project from scratch, and that's what I just did here. So this application started in 1.7 seconds. And remember, my machine is running a lot of stuff, so it could be even faster, but it's fast. Thinking that it is a Java application where you are bootstrapping a service that is listening and an endpoint and so on. Okay, it is fast, but when we have the same application, this very same application, being executed by using image created by using Graal VM, the same application started in 45 milliseconds. Okay, so we have here 1.7 seconds and here 45 seconds. So Quercus is not fast, as I told you, because of Graal VM, but yes, it can be faster when using Graal VM. So for example, as I told you in the beginning, if you would like to have an application that needs to start very fast, because you need to respond, have the first response very fast, so it could be a good way to have a native image. But if you have an application that have a much longer life cycle, maybe you should stick with the JVM, even the JVM of Graal VM, because the JVM already have a lot of good ways to manage the long life cycle applications, okay? So let's move back to my slides. I believe that it worked so far. I was just not finding the folder, but that's okay. Some of these examples I took from this article of this great guy that is Chris Seaton. It was one of the engineers of Graal VM. Now it's working in another company, but I will share my slide and you can go to this article and see much more code and examples. And one interesting stuff about Graal VM is that it's an open source project, so you can get involved and participate and so on. And back in a few months ago, they announced the advisory board. They created an advisory board of Graal VM. So these awesome people is now part of the advisory board of Graal VM. And interesting to see here that we have companies like Amazon, Shopify, Twitter, Graal, Red Hat, Neo4j, VMware, Oracle, and so on. So we have a lot of companies that even compete in some scenarios, but they are working together to create a great project, a great tool. And you can see, for example, another frameworks and other technologies using RhoVM, like I just said, Quercus. So it's great to have this cooperation, and I'm sure that the whole community will have a lot of benefits from it. Okay, so by ending here my presentation, I just would like to share with you this URL from developers.redhat.com. It's the Red Hat Developers website, where you can have a lot of content for you developer related to cloud native, to Java, to OpenShift, to Kubernetes, Istio, Service Mesh, and so on. And sometimes they send you also another mail to have some summarize of this content. So we have here the URL and the QR code. And Roberto, maybe if you have some questions, I can try to answer them.
Hey, Elder. Yes, thank you so much for your presentation. That was awesome. I mean, Graal VM is one of my favorite technologies these days. Yeah, I'm really excited about it. I started to look into it maybe like 2 or 3 years ago, actually, and when it was actually still starting. And it's quite nice to see how it turned out and having so many people getting invested into it. And we're now having this advisory board and a lot of other people working on that. So it's really cool to see that happening on the Graal VM space. Yes, we do have a few questions for you here. One of the first questions that I like to ask you is from Paulo Martins. He's asking, can we connect Visual VM to the native image?
Visual VM to native image. No, because when you create a native image, well, I need to check, but I believe that not. And I will explain why. When you create a native image, Graal embed on that native image what's called a substrate VM. Okay, so it's a very small VM with a very basic features of regular VMs, like garbage collection and some memory management. So I don't believe that it starts a Java process, but I can check and got you back.
Yeah, I'll add something on that. So actually, when you transform a Java program into a native image on Graal VM, when you run the native image, that's not Java anymore. There's no JVM behind it, right? So any tooling that you might have when you're trying to debug your application, it just doesn't work with native image, because native image is just a binary file that uses substrate VM, as you just mentioned, but there's not a JDK based VM for you to play with. So let me just add as well that one of the things that you might want to do is you can develop your application as usual, run it in VM mode. You can debug it as usual with VM working tools, and then when you're happy, then you just build the native image. So most likely it's going to work. I mean, of course, there might be a few issues, but usually, like if you're like dealing with application bugs, it's okay to do the debug like that.
Yeah, and we need also to remember that it takes a lot of time to create a native image. So it's not something that you spend every single line that you save and you create a new native image and then run, because you spend your whole day creating native image. So as Roberto just said, code and test and try. Once you are happy, then you create the native image and go forward.
Okay, a few other questions here. So one from João Rebelo. So he's asking, are there any plans for Graal VM / Quercus to go into feature parity with Java releases? So for what I understand with this is, as we know, Graal VM, it's lagging behind of the regular JDK versions. So I'm guessing the question is mostly, when are we going to have, if we're going to actually have releases from JDK and Graal VM at the same time that support the same version?
Well, I don't have the information itself, but what we have been seeing happening is that they are supporting the LTS version. So the first release of Graal VM was supporting Java 8, and on Graal VM 20 or 19.3, maybe they started supporting the 11. Uh, and we need to remember that, for example, if you download any regular OpenJDK starting on 10, Graal VM Git compiler is available on a regular OpenJDK uh, version, but as a incubating feature, as a experimental feature. So I don't know what plans that they have, but by now we see they supporting the LTS. And the same for Quercus. Okay, Quercus and RhoVM, they are not working together on this matter, but if you have been following Quercus so far, we've been seeing they following also the LTS, and maybe you, Roberto, can have much more detail as you are one of the Quercus engineers.
Yeah, I mean, we do try to support the latest version of Graal VM all the time, but as you know, it's quite hard to align the roadmaps, right? Because usually when a new version of Graal VM comes up, it does require some work on our end for Quarkus, and which basically means, let's just say we released Quercus like 2 months ago or 1 month ago, and then there is like a new version of Graal VM coming the next week. Then it means that we either have to hold on the release of Quercus to be able to incorporate those changes, or we will just have to release the new version of Quercus and then work to support the new version of Graal VM in the next version, if that makes any sense. So it's mostly like a play of trying to align the roadmaps, and of course, I mean, Quercus is a different product from Graal VM, and sometimes the roadmaps don't really align, and in some cases we're able to make really close releases to the next version of Graal VM. Some other cases we don't, right? It really depends on what's coming on the next RhoVM version, and especially for Quercus that we introduced the latest RhoVM version that adds support to JDK 11, and also on Quercus we're trying to drop the support for JDK 11 for JDK 8 and only support JDK 11. It makes things a little more trickier. Yeah, I mean. It, I mean, Java 8 is probably one of the most successful Java versions, right?
Yeah. It's the most used, maybe
Yeah,
80% of developers
yeah,
use.
but people have to realize, and I understand that it's hard for people to upgrade, but for us, for instance, framework maintainers, you have to realize that it's really hard to be able to do support for these old Java versions, right? Because the tooling and the APIs are not there anymore for the new stuff. So you guys want new features? Awesome, we all want to deliver them, but to deliver them, we also need to use the new Java versions because it's way easier for us, and then we start to lag behind. So that's a harder battle that we're battling right every day.
Yeah.
Yeah, but I do have a couple of other questions here for you. So this is coming from Fabio Silva. He's asking, can I use Graal VM with Spring Boot instead of Quercus?
Yes. Actually, I didn't share it here, but see, if you're just using a regular Graal VM, you are just using a regular JVM. So OpenJDK 11, for example, if you can run your Spring Boot application on a OpenJDK 11, you can also run on a Graal VM 20 that is based on OpenJDK 11. If we're going to use native images, they have some limitations. Okay, they are working on those limitations. They are less today than they were like 2 years ago, but they have limitations. So you need to try it. So get your Spring Boot application, try to generate a native image and see how it's going, because a lot of times works, okay, but sometimes you have some limitations, especially when it has inflection, configurations, you should have some limitations. But you should try because they are working very hard to resolve all those issues.
Cool. Just last question. This coming from Francisco Sejudo. So it's asking, why is not recommended using Graal VM for long life Quercus application?
Not Graal VM, but the native image. Okay,
yes, the native image.
Yeah, because
sorry. Some people sometimes do mistake Graal VM with the native image, right?
Yeah,
and that's something that we need to clear up.
Yeah, it needs to be very, very clear on your mind that one thing is just Graal VM, that is a Java virtual machine, and you can run wherever you run on a regular virtual machine, you can run on a Graal VM virtual machine because it is certified. I just showed you when I got Java version, you got the OpenJDK related, so it's certified, so it is a virtual machine. Another thing is a feature of Graal VM that it is generating native images. And so far, the native image doesn't seems to be the same performance or the same behavior that you have in long-term lifecycle applications as we have in a regular Java virtual machine application. So it's just these cases, okay? So that's why I told you that if you have an application that needs to start fast and respond fast and then die, maybe a native image would be a better approach.
Yeah, let me also just add on that. So one of the issues, well, not an issue, but one of the things that happens. Well, so if you know a little bit on how VM works or JVM works, yeah, you know there is a profiler, right, and the JIT compiler on runtime that what it does, it basically turns your bytecode into native code directly, right, and that's done doing profiling on what your application is doing. Right, so it's able to optimize depending on what you're running directly. But the native image, that work is done on compile time. So meaning that the profile is not as powerful at runtime. So the profiler in the native image of Graal VM is not as powerful as the JDK. So it's not able to optimize as much as it can during runtime. So, but as far as I know, the Graal VM team is working to be able to have the profiler and other stuff to be more optimized at runtime and have the same throughput or even better as any other VM process or JVM process. I'm not sure if you agree with this statement, Elder.
Yeah, absolutely. That's that statement. There's no silver bullet. You can't use the same tool for whatever challenge that you have. So you just need to pick the right tool for the right activity.
Okay, Elder. So we're pretty much out of time. So thank you so much for joining us for today, and thank you so much for this awesome presentation. I hope we can see each other soon around when they lift this travel ban, and hopefully can be here next year in Portugal.
Yeah, I hope so. Thank you, my friend, and thank you for all your audience for being here today. Thank you very much.
Wonderful. Thank you. Okay, bye-bye.
See you. Bye-bye.